Hello students, these are the notes for Unit 6, Lesson 1 on parallel lines cut by a transversal. It is the first lesson in the new unit on triangles and the Pythagorean theorem. Let's just start by breaking down the title of today's lesson, just to kind of understand what's going on. So that first part, parallel lines, we know that parallel lines are two lines that exist on the same plane that will never intersect, okay? So right here at the very top, we can see that these two lines are parallel, right? Horizontally parallel. Over here to the right, we see that we have two vertically parallel lines, okay? The other part of the title is that these parallel lines are being cut by something called a transversal. And we can see here that these two lines are cut by this diagonal line on each one. And that is something we call a transversal. And we're going to get into that in a moment. But you can see that when that transversal cuts those parallel lines, it creates a number of angles, right? You can see here angle 1, angle 2, 3, 4, 5, 6, 7, and 8. And these angles are in different kinds of relationships with each other. And we're going to describe those relationships, see what the relationships tell us about those angles. So let's start with this first definition, transversal. We're going to kind of define it more formally. It reads here, transversal. A transversal is a line that intersects two or more lines at different points, okay? So I'm just going to continue with the same kind of design here. I'm going to highlight these parallel lines, and this red highlighted line right here is the transversal, right? It's a line that intersects two lines at different points, okay? So that's just what it is. It's a transversal. Corresponding angles is something that we talked about in Unit 5 on similar figures. So it might seem somewhat familiar. Remember, corresponding means matching. It's a kind of fancy way of saying matching in math. So matching angles, and let's define it more formally. Corresponding angles are two angles that lie on the same side. I'm going to write this with a pen. Same side of the transversal in, I'm going to say relatively the same position. Corresponding angles are congruent. Okay, and again, that I know it's been 2 weeks since we had class, but congruent, if you remember, is just a math word for the same. Same. They're the exact same. Okay, let's try to understand that meaning from the diagram. Okay, so corresponding angles, two angles that are on the same side of the transversal in relatively the same positions, and they're the same. So I'm going to start by just highlighting the parallel lines in blue, and I'm going to highlight the transversal in red. So the first part of that definition is that they lie on the same side of the transversal. Remember, this red line right here is the transversal, and there are two sides to the transversal, right? There's the right side of the transversal, and there's the left side of the transversal. This first angle, angle that's, I guess, kind of represented by a black dot, I'm just going to draw a little angle, I guess, line there to just emphasize that it is an angle. That is on the right side of the transversal. Therefore, we need to be on the same side. So we also have to occupy the right side of that transversal. And the only angle that is on the same side and relatively the same position is this angle right here, which I'll represent in, let's do green. So right here, I'll do a green dot and create a green angle line. Those two angles are on the same side. They're on the right side of the transversal, and they're also in relatively the same position. What I mean by that is it's where the transversal meets the right side of the parallel line. Same thing over here. The transversal meets the right side of the parallel lines, okay? And even visually speaking, you can see that this is an obtuse angle, right? It is larger than 90 degrees. This is also an obtuse angle, larger than 90 degrees. But because we understand that corresponding angles are congruent, are the same, these are the exact same angle, exactly the same angle, okay? And we could take that knowledge and use it, for example, up above. For instance, on this parallel lines cut by a transversal on the left, Angle 1 corresponds to angle 5. Those are the same angle. Angle 1 and 5 are the same angle. Alternatively, angle 3 and 7 are corresponding angles. They're on the same side of the transversal, and they're in relatively the same position. They're the same angle, okay? So you can see that actually all of the angles are in a corresponding angle relationship with another angle. All right, next definition, alternate interior angles, okay? Again, it's a little bit dense, but we're going to define it, and then we'll kind of break it down from there. So alternate interior angles are two angles that lie on opposite sides of the transversal, and they are also congruent. Which, remember, is just a fancy word for they're the same angle, the exact same angle. So on the diagram to the right, we can see that this is that angle we're looking at, the black dot angle. I'm just drawing that little angle line to emphasize it. And again, I'm just going to highlight my parallel lines cut by this transversal, okay? So alternate, we kind of talked about this in class, but alternate is a word that means kind of other, right? So if you're making a recipe and the recipe calls for maybe butter, but maybe, it's late at night and you don't have butter, you might be able to use an alternate ingredient like oil or something. So alternate means other, interior means inside. So alternate interior angle means other side, opposite side of the transversal, right? And interior means we're still inside the parallel lines, okay? So if we look at the black angle over here, this is on the left side of the transversal. So we have to be on the other side. We have to be on the right side, but we have to be inside the parallel lines. The only angle that is inside the parallel lines and also to the right of the transversal that is congruent is the same, and I'll continue to use green, is this angle right here. So I'm going to do a green dot and this angle right here. Okay, and we can see that those look visually to be at least very close to the same angle, right? We have two acute angles. They're both less than 90 degrees. But because we understand this relationship now, we know that those are actually the exact same angle. They're exactly the same. All right, from there, let's define alternate exterior angles. Alternate exterior angles are two angles that lie on, again, opposite sides of the transversal, and they are also congruent. Okay, so the only different, operative word here is exterior. We know that the word exterior means outside, right? For example, the exterior of your house is the outside of your house. So this angle right here, I need to be outside. And again, I need to be on the other side of the transversal. This first angle is on the right side of the transversal, so I have to be on the left side. The only angle that is the same, that is also on the outside, is this angle right here at the bottom. These angles are alternate exterior angles, and they're the exact same angle. All right, keep in mind that this isn't the only possible angle, okay? For example, up here, right, angle number 2, maybe I'll do this in yellow. Angle 2 right here, it is in a relationship, an alternate exterior relationship with 7. These are the exact same angle, right? So maybe I'll put a little line there to indicate that those are the exact same angle measure, okay? So it's important to note that, right, there's lots of these relationships. For example, on number 1, this is going to be the same measure as angle 8, right? Because they're on opposite sides of the transversal, and they're both on the exterior. They're both outside of the parallel lines. All right, supplementary angles. This should be something that is somewhat familiar. It's definitely something you learned in past years. But supplementary angles are two angles whose sum is 180 degrees. 180 degrees. Remember, sum, that's just a math word for, right, when you add, you're going to add all those numbers up. So this is going to be true anytime you have a straight line. So in class, I asked if there were any skateboarders or figure skaters, people who, enjoyed those kinds of performance sports. And we can see here, for example, this is a straight line. We have the black dot angle, which is right here. And we can see that it lies on a straight line, which I highlighted in blue. And anytime you have a straight line, the two angles that are on that straight line are always going to add up to 180 because 180 is a half circle, right? It's a semicircle. Some of you are probably all of you are familiar with the idea that 360 degrees is a full circle. Half of 360 degrees is 180 degrees, and that represents a half circle. So we can see on a straight line, and here maybe I'll zoom in and I'll kind of redo this just to, I guess I should use the eraser. We'll redo this line just to kind of emphasize that this is a half circle. But we have this first angle, right here. And then we can see if we represent the right side of this angle in red, we can see that that creates a semicircle, right? A half circle. So anytime you have two angles or even more angles, but in this case, two angles on a straight line, they're always going to add up to 180 degrees because that's a half circle. And we can see right here very clearly that is a half circle, right? Not perfectly drawn, but a half circle nonetheless. Okay, so any two angles that add up to 180, that's supplementary. Next, vertical angles. Vertical angles is something we saw in the previous units. It's two angles that are, I like to say across, but you could also think of it as opposite from each other. And vertical angles are also congruent. And reminder, congruent just means they're the exact same. They're the exact same thing. All right, so we can see here on our diagram, we have this black dot angle right here. What we mean by across, or what I like to think of as across, is kind of right here, right? It's on the other side of that intersection right there. So these two angles, the black angle and the green angle, those are vertical angles, and they're the exact same angle measure. So we can see they're both obtuse angles. They happen to be the exact same angle. All right, this last one is the strangest one that we've seen, but we're going to kind of define it first, and we'll break down why, it is what it is. Okay, so same side interior angles are angles that lie on the same side of the transversal between two lines. Same side interior angles are supplementary angles. Okay, so remember, we just defined supplementary angles 2, definitions ago. Supplementary angles are two angles whose sum is 180 degrees. So all this is really saying is in same side interior angles, right? And I'll just put this in parentheses, and maybe I should actually use the pen. They are going to add up to 180 degrees. Okay, that's it. All right, so let's make sense of that from the diagram. We have our black dot angle right here. I'm going to highlight our parallel line just to kind of make this a little more clear. So we have our parallel lines right there. They're cut by the transversal, that line that kind of cuts through the two of them. So remember, I have to be on the same side of the transversal, in other words, the right side, and I have to be interior, which means inside the parallel lines. The only line it could possibly be, or the only angle I should say it could possibly be, is this angle right here. It's on the right side of the transversal, and it is inside those parallel lines, okay? It should be quite clear that these two angles are not the same angle, right? They're not congruent because one is obtuse, one is acute, but it is actually true that they are supplementary, meaning they add up to 180 degrees. If you're having a little bit of trouble understanding why, I'll just kind of do a mini proof here. Because we know that corresponding angles are congruent, we can say that this is the exact same thing as the black angle, right? Because they're on the same side of the transversal, and it's also in relatively the same position. So we can agree that the two black dot angles are the same, and we can see right here, maybe I'll do it in yellow, that these are both on the same line. So this creates that semicircle, that half circle. Remember, if you're on a line, two angles on a line always add up to 180 degrees. So therefore, the black angle plus the green angle is equal to 180 degrees. Okay, so that's just a mini proof. You don't necessarily need to know that or be able to prove that. But you should know same side interior angles, those are supplementary, meaning they add up to 180 degrees. All right, the next page we did together in class is the guided practice. So what I think is the most valuable is to actually, in a way, have your notes kind of on one slide and be able to, I guess, compare the angles in the guided practice with each other just to kind of see them side by side. So I'm going to try to recreate that by just being really zoomed out. So we're right here on number 1. We have our 2 parallel lines. They're cut by this transversal. And I'm going to kind of use a finer pen here. We have this angle, which is 68 degrees. And let me use the pen, actually. That should be fine. 68 degrees right here. X degrees right there, okay? So looking at number 1 and looking at our notes, you just have to ask yourself, what kind of relationship does that look like? So it's either going to be corresponding, alternate interior, alternate exterior, vertical, or same side interior. Or it could be none of them. Actually, there's one, number 5, I'll just tell you right out the gate. Number 5 is a little bit tricky because it's not one we formally defined, but it is something we can still figure out. So number 1, to me, looks like corresponding angles, right? So I'm just going to write that for you, corresponding. Maybe I'll write in blue. Okay, these are corresponding angles. Let me write angles. Okay, corresponding angles. And based on our definition, we know that corresponding angles are congruent. Congruent. Okay, congruent means they're the same. So if the angle 68 degrees and x degrees are the exact same, we know that x is equal to 68. Right? Because they're the exact same angle. All right, great. Number 2. Let's look at number 2. Again, I'm going to draw my parallel lines. The way I did this in class was very much student-driven, I should say. Students would just look at it and tell me what they thought, what kind of angle they thought it was. So we can't exactly recreate that here in the video, but we can try. Okay, so we have our 2 angles here. Looks like they're both on the same side of the transversal, right? They're both on the bottom side of the transversal, and they're both inside the parallel lines. So that looks to me to be same side interior angles, right? Same side interior. And let me write in blue. Same side interior angles. And if you check your notes, these angles are supplementary. Okay, supplementary angles mean they add up to 180 degrees. If I know that x plus 134 is 180 degrees, all I have to do is subtract 134 from 180 in order to find x. So my calculator here next to me, 180 minus 134 is 46 degrees. So angle x is 46 degrees. All right, number 3. Again, we have parallel lines. These ones are horizontal. Maybe I should adjust the thickness of my highlighter. There we go. Horizontal lines cut by a transversal. And we have 2 angles here. We have the 120 degrees here. X is right there. Again, I recommend looking at your notes just so you can kind of compare them side by side. I'm just going to stay on this slide for now. But you look at those side by side, and you're going to see that these look a lot like vertical angles. Vertical angles. And we know that vertical angles are congruent. Which again, reminder, means they're the same. They're the same. Okay, so if 120 degrees is the same as x degrees, x is equal to 120 degrees. Okay, very simple. So it's just a matter of identifying it. You're not necessarily going to be super good about memorizing all the relationships and exactly what they are. I really want you to verify what you know based on the notes. So this is kind of one of those activities, one of those assignments where I highly recommend having maybe your notes on one tab or one side of your screen and having the assignment on the other side of the screen so you can constantly just verify, double check. All right, number 4, vertical lines. Or sorry, not vertical lines. They are vertical lines, but parallel vertical lines. In our transversal, we can see those angles are here, 101 degrees, x degrees, okay? So just looking at those, kind of pondering, well, they're on different sides of the transversal, so that might be something like alternate, and we can see they're both inside the parallel line, so these are alternate interior angles. Alternate interior angles. And those angles are congruent, meaning they're the exact same. So if 101 is the same as x, x is 101 degrees. Great. Let's look at 5. Okay, this is one I said is going to be a little tricky because we didn't define it formally in our notes, but that's okay. We're smart. We're going to figure it out. Ooh, forgive me. Let's see. Let's try nice. There we go. All right, so we have our 2 angles here. We have angle x and angle right here, 77 degrees. Okay, they're both exterior. They're both outside the parallel lines, but they're both on the same side of the transversal. They're not alternate. They don't look like they're the same angle, right? Because one is obtuse, one is acute. This is actually going to be called something called same side exterior angles because they're on the same side of the transversal. It's on the outside, right? The exterior of the parallel lines. And these angles are going to be supplementary. Okay, the way I would justify that, I think I did this in some of my classes, is this is actually the same thing as x degrees, right? Because those have a relationship of alternate exterior angles, which are congruent. So this is also x. And you can see that these 2 angles are on a straight line, right? And they make a semicircle. So they add up to 180. I know that looks a little messy, but they add up to 180, okay? Anytime I have 2 angles that are supplementary, right? They add up to 180. I just subtract the known angle from 180, and I'm going to find the missing angle. So if I do 180 minus 77, you get 103. So x is equal to 103 degrees. All right, fantastic. 6, we have 2 parallel lines. Here and here, we got our transversal, cuts right through them. We have our 2 angles, 106 degrees, x degrees, okay? Looking at those, right, they're both inside. They're on opposite, alternate sides of the transversal. This looks like alternate, and actually, forgive me, let me make sure I'm writing in blue. Just keeping it nice and consistent. This is alternate interior. Alternate interior angles, right? Because they're inside the parallel lines. They're on alternate sides of the transversal. These are also congruent. I'm just going to write the same. They're the same. So 106 is the same as x. So x is 106. Just 2 more. 2 more. Number 7. Again, parallel lines. Maybe I'll do number 8 too. We have our parallel lines here. And transversal. It's the thing that cuts across them right there. Right there. And these are angles here. This one and this one. 142 here and x here. All right, let's look at number 7 first. Again, we're on the same side and we're interior. So these are same side interior. We know those are supplementary. And that's based on our notes, right? So we know that if it's supplementary, it adds to 180. So 180 minus 74 is equal to 106, which means x is 106 degrees. Right, again, so just really quickly. Remember, supplementary means this angle, 74 degrees, plus x degrees is equal to 180 degrees. So the way we found x was we were just taking 180 minus 74. That's equal to 106. So that's where we're getting that number. And I'm using a calculator. So you don't need a calculator. I think most of you don't need it for this kind of calculation. But if it helps you think about it or kind of calculate it quickly, remember, the calculator is something we want you to use. Number 8, again, we have our parallel lines, right? The transversal. These are both outside of the parallel line, so it's exterior, and they're on alternate or opposite sides of the transversal. So we have alternate, exterior angles, okay? We know that these angles are congruent, which means they're the same. So x is equal to 142 degrees. Okay, so in summary, we were able to, after defining some of those angle relationships, we're able to make informal arguments about angle measures, missing angle measures, and we're able to find them because we understand some of the relationships, right? Corresponding angles, they're congruent, right? Alternate interior angles are congruent. Alternate exterior angles are congruent. Vertical angles are congruent. Same side interior angles are supplementary, right? Same side exterior angles are supplementary. So there's all these different kind of relationships between the angles happening. And, because we understand some of the definitions and, I think most of you probably could guess that these are the same angle or that they kind of add up to 180 degrees. But, we have a more formal definition for those, so you can make those arguments standing on, I guess, stronger ground. I'm just going to really quickly show you what today's assignment looks like. It looks like this. It's a big maze, okay? The way you navigate this maze is you're going to start in the top left, right up here with the start, and your goal is to move through the maze, depending on your answers, all the way to the bottom right, to the finish. So I'm just going to kind of show you how this works on the first one. So over here, looking at the start, you're welcome to highlight this if you want. But just looking at that, you can pretty clearly see that we have alternate interior angles, which we know are congruent. So between your two choices, right, we're here at the start, we can either go to 80 degrees or 100 degrees. These are going to be congruent, the same angle. So we're going to move to the right, okay? So we're going to move this way. I'll just draw a little arrow there. I guess you could fill in the whole thing. That's fine. Okay, that means our second question is this one to our right, okay? And looking here, okay, we can see that we have a obtuse angle, the 110. We have the x. This isn't actually a definition we formally defined, but using, for example, corresponding angles, we know that this angle is also 110 degrees, right? Because these are corresponding. They're matching. They're in the same side of the transversal. They're in relatively the same position. And these are both on this straight line right here, right? So they create a half circle, a semicircle, right? And here I'll show you that maybe in yellow. That's a half circle between these two angles. So those add up to, they're supplementary, add up to 180. 180 minus 110 is 70. Okay, so our next answer is 70. Okay, so I'm going to zoom out. That means I'm going to fill in this arrow right here. So I move this way from here to here. All right, that means this is my next problem, okay? And again, you're just going to continue this on and on, right, until you get to the finish. So I'll do this last one with you as well. Right here, it's pretty clear that these are vertical angles. Vertical angles are congruent. They're the same. So x should be equal to 120. So next I'm going to move in this direction. This direction. Okay, and you're just going to continue that all the way until you get to the finish. Again, one procedure that we're practicing this year, or for this semester, I should say, it is a new year, but for this semester, is make sure that once you finish the assignment on Canvas, on ClassKick, that you submit it on Canvas as a text document. You just need to tell me that you're done, just to kind of formally submit it for grading. Again, I'm going to be reminding you that throughout the year, throughout the early semester, especially just kind of building, I guess, that procedure, and we're going to practice. And anyway, I would really appreciate if you could do that. Thank you so much for watching the video, if you watch the video, and best of luck on the assignment.